So previous videos we've seen system classification and the problems of system classification, and this one is we have to see signal classification and what are the problems available in signal classification. So first of all, we have to see what is classification of signal. So they have the categories continuous time signal, discrete time signal, and deterministic and non-deterministic signal, and even and odd signals, periodic and aperiodic signal, energy and power signals. So what is continuous time signal and discrete time signal? So this is an example for continuous time signal. So the continuous time signal means defined as all instant. So it is defined for all instant of time. So discrete instant. So the signal said to be continuous when it defined for all instant of time. So discrete time signal is said to be only discrete instant of time. So then a deterministic and non-deterministic signal. So deterministic signal is no uncertainty. So the signal which can be defined as exactly mathematical formula allows deterministic signal. Signal said to be deterministic if there is no uncertainty with respect to the value of any instant of time. A signal which can be defined exactly by mathematical formula that is known as deterministic signal. So we can define by mathematical formula that is called a deterministic signal. Otherwise, it is non-deterministic signal. So this is non-deterministic signal example. It's uncertainty. So previous one is also there is no certainty. So deterministic signal is no certainty. This one is uncertainty. So the value is it's a random signal. So it's like noise. So we can be described. We can't be uh, do any kind of formula for this. So it's non-deterministic signals. And even that signal. So signal said to be even. It satisfies the condition of x of n is equal to x of minus n. So this is even. So it's a conditions have to satisfy. So now x of n, so this is x of n and this one is x of minus n. So both is like have to equal. So this is even signal. So the folding, if folding about the signal, we have x of minus n. So this is even signal. And add signal, x of n is equal to minus of x of n minus 1. So this is even signal, and this one is add signal. So up and down. So even means it's ups. This is for discrete time signal. Previously we seen about continuous time signal, and this one is discrete time signal. And periodic signal and aperiodic signal. So a periodic signal is a formula x of t plus t x of t. So this is periodic signal. So the signals are periodically it will be varied and the same pattern. And aperiodic also the signal. This one is aperiodic signal is starting from zero. So previous signal is started from infinite. It can be started anywhere. So periodic and aperiodic started from zero. And energy and power signal. So energy and power signal, it's you know identify. First of all, how we can identify it is energy or power signal. So signal it's a finite duration and finite magnitude. It always will be energy signal. And signal with infinite duration and constant magnitude are always power signal. All periodic signals are power signal, but the opposite is not. Signal in which magnitude tends to zero, then time tends to infinity are energy signals. So energy signals are absolutely integratable signals. So energy signal and power signal. So energy, so this is an energy signal. Uh, so equation for energy signal is n is equal to infinity x of n whole square, and then this is a power p. Power is equal to, so this is power equation. So average power is equal to limitation of n is equal to n tended to infinity 1 by 2 n plus 1. So this is a equation for power signal. So then was periodic signal and aperiodic signal equations. So this is a equation for periodic and aperiodic, and this is the equation for even signal and add signal. This is we already seen. And classification of problems. So see the energy and power problems. So x of n is equal to 1 by 2 power n whole power n. U of n is unit step signal. So you just you see that e is equal to, so unit step signal is there. So unit step formula is there. U power n is equal to 1. When it will be 1 is 0 and more than n is it, n is equal to 1. So summation of infinity n is equal to 0, 1 by 2 whole power n divided by, so you just apply what is n value, you just apply then x of n values. then if you apply that, then the value will be changed because of the square is there, so it is 1 by 4. So we know the formula, summation of n is equal to 0, a power n is equal to 1 by 1 minus a. So if a power n means 1 by 1 minus a, so this is like a, so 1 by 1 minus 1 by 4. So this is the equation, 1 by 1 minus 1 by 4. So you have to take it LCM. So automatically 4 minus 4 divided by 4. So 4 will be go to there. C. So this one is 4 minus, okay, 4 will be go to there. So the remaining value will be here. So E is equal to 4 by 2. So power, this is energy value, and power value, there's a formula they given. So limitation, so we have to apply that instead of x of n 1 by 4. So we have the formula, so a power n 1 minus a n plus 1 1 minus a. So we just apply it. If instead of a, one put it as this value 1 by 4. So this is a formula. So we have to apply for this a power n instead of a power n. So this is a considered as a. So we have to apply it. So 1 minus 1 by 4 n plus 1 1 minus 1 by 4. So by substituting the limit, we get it p is equal to 0. If you apply the n is equal to infinity, then we get it 0. So power is 0, hence the signal is energy. So because energy we got the some value, power there is no value, so the signal is energy signal. So similarly, same examples we have, then periodic signal and aperiodic signal. So that is also x of n sine 3 pi n cos 2 pi n, and x of n is equal to cos n by 2, x of n sine 3n cos. So these are the examples we are given. They already we shown the formula, periodic and aperiodic signals formula. So just apply the formula and you will get the values. And even and add signal, also we have the formula, you just apply it. You will be whether the signal is add or even, and the casual and non-casual signal, they have the formula. So just apply it, and the convolution sums and multiplication. So these are the example for signal classification problems.